Okay, ladies and gentlemen, this is chapter 1.2, Drawing Conclusions from Data. In this section, there are four main elements that you need to be very aware of. Okay, so what we're going to start doing is we're going to start statistical problem solving process, and the four elements are as follows. The first one that you must always start off with is ask a question of interest. A statistics question involves some characteristic that varies from individual to individual. And we'll go over a couple examples here in a second. The second thing you must do is once you have asked your question of interest, is you need to produce the data. So producing data could be, you could choose either an observational study or you could choose to do an experiment. Either one of those two would help you produce data. The third thing you must do is once you have your data, you need to analyze your data. And when I mean analyze, we'll discuss this in chapter 2, but we're going to start creating graphs, numerical summaries. You'll hear a five number summary, or you'll hear me talk about CUS and BS. That's CUSS and BS. And those things are you're going to be learning in the next chapter on how to analyze the data. And then the last thing you're going to do is you're going to interpret the results from your data. So you're going to produce the data, analyze the data, and then you're going to interpret the results. And interpreting the results of the data should help answer the question of interest. So again, the first thing you're going to do is ask a question of interest. All right? Ask a question of interest. Then that's going to lead you to produce data. So this is your second thing. Once you have produced your data, you're going to analyze your data. So that's the third one. And then once you have analyzed your data, you're going to use it to interpret the results. That's number 4. And again, this is to help you answer the original question. All right? So let's take a look and ask the question, who has tattoos? Do you have a tattoo? Does anyone in your family have a tattoo? So the question or the question of interest or the topic is, and if you'll read here, what percent of U.S. adults have one or more tattoos? Okay, there's your question of interest. The next thing you do, you either produce the data or you go research and see where the data, if someone else has produced the data. And in this case, the Harris poll, which you can Google, conducted an online survey of 2,302 adults during January 2008. Notice how specific they are in producing the data. According to the published report, okay, it is published, so therefore you can go check out some other published items as well. Respondents for this survey were selected from among those who have agreed to participate in the Harris Interactive Surveys. All right, so notice they have produced the data. So we've got the question of interest. Then we have gone and researched and checked and found out where the data was already been produced. The next thing is we're going to analyze the data. Analyze, remember, we're going to look at some graphs. We have a pie chart, and if you notice in the pie chart, 86% said no, 14% said yes. Notice they add up to 100%. Always make sure you analyze your graphs. Now, from those who surveyed, 14% said they had one or more tattoos. Did the responses differ by gender? Well, let's check it out. So now we have another chart that divvies up the female to male ratio. So, says percent with tattoos. So this relates to this. So of the female, according to this, 13% of the females said yes. So this is around 13%, as opposed to 15%. So it's almost even. Almost even. So the question was, did responses differ by gender? Not too much. All right, and you can be very specific about that. And the last thing we're going to do is we're going to interpret the results. Notice, interpret the results. And basically this restates and answers the question of interest. So notice it's going to answer that question. In the sample of adults, 14% said they had one or more tattoos. Of course, a different sample of 2,302 adults might yield different results. So they've also, put that in there as well. You won't get the same responses every time you do a survey, okay? That's the idea of sampling variability. If this sample is truly representative of the adult population, again, representative of the adult population, then we would expect 14% of the population to say they had at least one tattoo if asked. So again, the question is, do you have a tattoo? Do you know someone who has a tattoo? Okay, let's look at another question. Nitrogen in tires, is it a lot of hot air? Clever little title. All right, some of you who drive might notice that currently a lot of the car places are filling up their tires with nitrogen. All right. Some people started doing this because they thought that the nitrogen would stay in your tire longer. So, as you're sitting around the coffee table or sitting around the dinner table and so forth, maybe a question like this pops up. Does filling automobile tires with nitrogen improve safety, performance, or both? Well, doing a study like this, which one would you choose? Would you choose an observational study or would you choose an experiment? If you choose an observational study, how would you go about observing or who would you observe? If it's an experiment, how would you create the experiment? Or would you rather go to the internet and research to see if someone else has done this? Well, luckily for us, Consumers Union designed a study to test whether nitrogen tires would maintain pressure better than air-filled tires. Notice how complete that sentence is. All right? They're telling you what they are doing. They obtained, notice what they did. They obtained pairs of tires from several brands and then filled each tire with air and one with nitrogen. All tires were inflated, so it's giving you some details. Each tire was inflated to a pressure of 30 pounds per square inch and then placed outside for a year. All right, they're telling you that they're both under the same circumstances. They've both been placed outside for a year. At the end of the year, Consumers Union measured the pressure. So not only did they put each tire out there in the same element, then they measured it. Okay, they measured it. So that's producing the data. So again, 1 is ask the question, 2 is produce. If you remember, step 3 is analyze the data. So let's analyze and see what they did. The amount of pressure lost. So basically, if you notice, they have a list of all the tires that they had. Here is the air. Here is the nitrogen. Again, they start over here with Pirellis, and they go down. All right. Now, you have an option. You're going to analyze the data. You could graph air, and you could graph in a different graph nitrogen. What kind of graph do you think we could produce? These are numbers with tenths digits. All right. Would you make a scatter plot? Would you create a bar graph? What kind of graph would you make? Something to ponder. All right. You could also choose to compare tire to tire. And you could create what they call a dot plot. Or you can create a graph that will, I guess, show you, or a dot plot would show you basically, it could show you the plus or minus of how much was lost. Like for instance, from air to nitrogen, it's a difference of 0.4. So 7.6 minus 7.2 is 0.4. 3.8 minus 2.5 is 0.7. I'm sorry, my mistake. 0.13. I guess my math is not very good today. So 0.13. 1.3. Again, I messed up. 1.3. So on and so forth. This difference is 1.1. So notice those are all positive. Those are all positive. Would you have some that are negative? It is possible. For instance, 3.1 minus 3.4 is a negative zero point 0.3. So you could use a dot plot to see if there was more that increased or more that decreased. All right? And the last thing you do is once you have produced your data and you analyze your data, you're going to interpret the results. Now notice how thorough they are in the results. In the tire pressure experiment, they stated the experiment, the air-filled tire lost more pressure than the nitrogen-filled tire for 28 of the 31 tire pairs. That's very significant. So is that random, or do you think there's something to it? There are two possible explanations for the results. So notice how they're preempting that there's two results. Filling the tires with nitrogen rather than air caused reduction in pressure loss, or filling tires with nitrogen rather than air did not reduce pressure loss. But just by chance, the tire was going to lose more pressure anyway, happened to get filled with air. So you got to consider these things. Was it by chance, or is there something significant to what you're asking? So it says, imagine flipping a coin 31 times to simulate assigning air and nitrogen to all 31 pairs of tires. So it's giving you an alternative, saying, hey, think about this. It says there's virtually no chance of selecting the tire that will end up losing more pressure in 28 of those pairs to fill with air. So as a result, it's saying part number 2 is not plausible. It's not possible. Based on the results, notice that they're referring back to the original analysis. So based on the results of the experiment, we conclude there is convincing evidence that filling the tires with nitrogen rather than air caused a reduction in pressure loss. So notice how thorough the interpretation is. All right. Now, you're not going to have to do all 4 of those things right off the bat. We're going to do it step by step, chapter by chapter. So, the first part you're going to do is part A. We're going to analyze data, chapter 2 to chapter 4, chapter 2, 3, and 4. Once we are done with those 3 chapters, we're going to go into part B, which is producing the data. So that you're going to start doing experiments, you're going to start doing observational data, and that's going to be in chapter 5 and 6. When we get to part C, we're going to talk about things happening by chance. What are the chances of this happening? Was it just dumb luck? Was there a method? Or was there something to it? In other words, was there really some validation of filling the tires with nitrogen as opposed to air? And then finally, the last thing is inference. Inference. And what that's basically moving beyond the data in hand to draw conclusions about some wider universe. Done properly, inference is going to allow us to estimate some characteristics of a population based on a result from a sample. All right, could this result have happened just by chance? This is where we're going to answer that question. Again, back to part C with chance. This gives us the language we need to describe variation and risk and probability, which you hear a lot of insurance companies use. So because variation is present in statistical problems, we need a deeper understanding of the role that chance plays in contributing to that variation. All right, and this concludes today's lesson. Hope you enjoyed it, and I hope you didn't stay up too late to listen to it. It is 14 minutes long, which is a little bit more than what I would normally record. Thank you, and good night.